I should also say, if you were reading the printed program and expecting to see Mike Hanley, he and I were originally planning to do this together, but he couldn't make it, so you just got me.
You got the desk.
So I had an interesting week last week. It was 2 Sundays ago. I went to sleep after seeing some Twitter traffic. Like, oh no, tomorrow morning, everything to do with Wi-Fi security is going to be broken. And sure enough, wake up in the morning, there's the crack attack, and there wasn't all that much to it that was relevant to us, except the need to install patches on all of our endpoints. And update your shit is basically a mantra at Duo, so that's not a big deal. But I also saw this. There's a second major disclosure that happened, which was that this Infineon library that was used in the firmware of all of these sort of crypto hardware devices, secure elements, smart cards, HSMs, whatever, had a real big problem in it where it was generating weak RSA keys. And weak means like you could, in a practical amount of time, factor them, which is, kind of defeats the whole purpose. And so why did this matter to me? It's honestly, for a lot of people, probably a pretty esoteric issue. But for me, well, last year, I went through this process where we heavily adopted YubiKey 4s at Duo. And we use them for a couple of things. One is the universal second factor protocol. This is what you're using if you do security keys with Google or Facebook, things like that. That was completely unaffected by this vulnerability, by the way. If you're doing that, don't worry about it. But there's another feature of the YubiKey, which is kind of a little bit less commonly used, but basically it can speak the same protocol as the DoD CAC cards, which means it can generate and store RSA keys and use them to perform signing operations. And I'll say that the real point of this is that it can generate and store keys, but it will never allow the private key to be extracted. So possession of this physical device means that you alone have the private key. Or that's the idea. Turned out that was not true. So last year we went through this process where we handed out 100 of these, had everybody generate their SSH keys and hardware. It was going to be great, real step forward in security. And then I wake up a week ago, Monday, and learned that actually it was the exact opposite. Everybody had weak keys because of this thing I'd done to try to improve security.
So that's an Infineon chip is in the YubiKey.
Yeah. As far as, I don't know if it's Infineon hardware or just the Infineon firmware library, but yeah.
It would be bad.
So basically we had to do a fire drill where we rotated everyone's keys. Well, if you believe in the sort of FIPS certification stuff, which honestly I have some problems with it, let's not get into that. But they're seeking, I think, level 3 on these things, which involves a lot of guarantees about tamper-proof hardware. They haven't completed that process yet. Anyway, so there was some grumbling along with this process, right? And I'll pick on Rich Smith, who's our director of R&D, for just a minute, where he said, he tweeted this. He's like, hey, maybe, you've got major stuff to share. Don't drop it Monday morning. And, I'm sure. I kind of agree with this. Maybe just because this made my Monday morning suck, but and in the past I've certainly said, and probably publicly on Twitter, things like this. Many times when I've seen somebody disclose something somehow that I don't think was done in the most productive way. I've got a laundry list of examples of this. But I'm not going to talk about them here. I'm not going to name any more names in this talk except my own. But I think what we should take away from this is that doing disclosure well is maybe kind of tricky. So, and I'm particularly talking about doing disclosure as a vendor, because that's kind of who I am or who my employer is. So I'll start with the good news. The good news is that there are actually some pretty good standards on this. And if you're a security vendor and you don't have a strong disclosure program or you think it could use some improvement, then read this document. It's available for free online. thanks to efforts of some smart and dedicated people, because it cost money when they first released it, which was really stupid. But anyway, it's a real good sort of general framework for the basics of what you should have in place. It says, hey, you should have a single point of contact for where people, if they find a vulnerability in your product, they can report it. You should have these sort of minimum expectations of communication with the reporter, like make sure that they're kept in the loop of when you've reproduced it, when you've fixed it, et cetera. And then it kind of also goes into some details on the other side of this, which is once you have figured out what's going on with this report, say confirmed that it's a real vulnerability, figured out some remediation, then here's kind of the structure of what you likely want to send to your customers. Here's a bunch of sections you might want to include when you're writing up a security advisory. And there's really a lot of good information in there. And what I'll say is read it carefully. There are some sentences that seem kind of like subtle, unimportant points, but several of them are based on real-world experiences where not following that particular bit of advice resulted in bad experiences for people. So there's some good stuff there. But as I said in the talk abstract, if you search for the word empathy in this document, you won't find it. And what I'm not trying to say that there's anything wrong with the standard. I'm just trying to say that it's kind of the starting point and not the end. We started, we first kind of drafted a vulnerability disclosure policy at Duo in 2014, based largely on this document. But we've learned a lot of lessons since then, and some of them kind of the hard way, like through pain and suffering. And the main point that I want to make kind of in the entirety of this talk is that if you really, as you're going through this process, try to put yourselves in the shoes of your customers and understand what it is that they need from you as you're doing this, then chances are things will be at least okay. But if you forget that, then you and your customers could have bad experiences. And so I'm going to kind of spend most of the rest of this talk going through one specific case study from earlier this year. This was a kind of disclosure activity that we did that was probably one of the most complicated and labor-intensive of anything we've ever done along these lines. But in our opinion, I think it went pretty well. Not perfectly, of course. And oh yeah, by the way, I should say, if you see this acronym PSA, we say that as Product Security Advisory. That's just like the acronym we came up with. It's not necessarily a standard or anything. But Product Security Advisory, not public service announcement. Somebody even pointed out that my title, Principal Security Architect, has the same letters, so well, okay. So this vulnerability had to do with a piece of our product we call the SelfService Portal. And not a product pitch, I promise, but I got to go through a little bit of how this is supposed to work before I can tell you how it broke. So basically, our sort of core product offering, what we've been doing all these years, is strong user authentication. So if Alice is trying to log into her Acme Corp email account, she'll enter a username and password into some form, and then she'll be taken to see something like this. We call this the Duo prompt. Here she is given some options based on what her administrators have decided she should be allowed to do to authenticate through push or passcode or whatever. She'll choose one of those, get logged in. But we added some more stuff. So say Alice gets a new phone. We wanted to make it possible to reduce the burden on her employer, Acme Corp's IT staff, so that Alice could sort of manage her own devices and say like, hey, I have a new phone. And what she would do is, instead of completing the login to her email account, she'd click this add a new device link that the arrow's pointing to there. And that would require her to do two-factor with one of her existing devices first. And then she could get to a screen like this and manage her settings, add new devices, whatever. But there was a problem with all of this, which was that there was a logic bug in our application where we didn't properly enforce that whole requirement that Alice had to do two-factor with one of her existing devices before adding a new one. The way to trigger this bug was, a little bit subtle because you had to start two-factor, but you didn't have to finish it successfully. That auth attempt could fail, but you could still manually type in the URL for the next step and you'd get there, which is not great. That's honestly, it's kind of an embarrassing bug. And so what this means, the real sort of broadly stated impact of this is that if I'm an attacker and I've stolen Alice's username and password somehow, then I can log into the SelfService Portal with just those two things, add a new authenticator, say my own phone, to Alice's account, and then at that point, I have Alice's primary and a valid secondary credential for her account, and I can log into her email and do whatever. So this slide is just kind of the overview of the timeline of what happened here. I'm not going to talk about this much because I'm going to go through all of this in detail. But the thing to keep in mind, I guess, is that we went a little over a month from the initial report to the sort of final advisory notification remediation steps. And what I'm going to get into is kind of how that time was divided up and why that happened. So the first thing that happened, of course, was that we received this report from our customer, from one of our customers in this case. And interestingly, the report came in through sales. The customer contacted their account executive and said, hey, I found this weird, maybe security vulnerability in your product. Sales happened to be having their 2017 kickoff event, which was like an all-day pep rally, party, whatever. But the account executive in this case kind of immediately recognized that this was serious, and within 20 minutes had called up the security team and said, hey, I just heard a thing from this customer. Maybe you want to take a look at it. One other thing I'll say is that not this time, but in the past, we've had vulnerabilities come to us that the customer didn't even realize it was a vulnerability. They contacted our support team and said, hey, a weird thing is happening. Maybe I misconfigured the product. And then the support team and maybe engineering, through escalations, did some investigation. They're like, oh no, that's a vulnerability. And they reported it. And of course, they have known at that point, go to the security team. We've spent a lot of time and conscious effort cultivating security awareness in our organization. And this has proven quite valuable because even though the sort of standards say like, hey, you should have a single point where external people can go to report vulnerabilities to you, in practice, that's not how most of them have come in, at least in our experience. And so having everybody in the company know that A, security is important, B, if there's a security thing, you should send it to the security team, then this has helped us maintain awareness of things and get reports promptly a lot of times. It's had some slightly perverse consequences too. We have done such a good job of making people completely afraid of phishing that when we actually send real emails out to the company, we have to include proof of life. I think that was on the solar eclipse day, which is why Steve and Jamie are wearing the eclipse glasses. So anyway, we, security team, kind of received word of this vulnerability, and they included a helpful video showing the whole process. So it was actually pretty easy for us to look at that, say kind of like, oh crap, that's real. And then, there's this question at this point where we say, is this going to be a case where we need to run our vulnerability disclosure playbook? And basically, there are specific triggers that push us towards yes, but really the answer is if this seems like it might be a thing, then assume yes, and later if you figure out it's not, you can always just say never mind. But run the process until you're sure you don't need to. Ultimately, I think the last two bullets under that section are the real cases when eventually we consider an advisory to be necessary. It's if either remediating the issue is going to require customers to do something, or if they could have been, their security could have been impacted by this vulnerability, like if it was possible that some attacker had actually exploited it and done bad things. So after we finished triage, kind of immediately on to figuring out how to fix this thing. And another brief aside is that our CTO, Jono, decided to step in and buy us all pizza so that because quick bug fixes require sustenance. And our favorite pizza chain up in Michigan happened to have a deprecated SHA-1 certificate. So we may be the only ones who have ever switched to a different pizza chain because their SSL cert was bad. They have fixed this since then, so we have gone back to ordering Marcos sometimes. Overall, we went from the initial report to having a fix not only implemented but fully deployed in 25 hours. And this is in part because the bulk of our product is a cloud-based service under our control, so we can patch things ourselves. Sometimes we have vulnerabilities in kind of on-premise connector components, and that's when we have to send out a notification telling customers, hey, you need to upgrade. In this case, it was a little different because the patching itself was something we could do entirely by ourselves. It was a relatively simple fix. Fortunately, not everything would go this way. And also just really strong partnership with our ops, or we call them production engineering people, to get some new code deployed out of a normal release cycle and without causing any downtime, bad impacts for our customers. We normally release code every 2 weeks, which is pretty frequent. It's not continuous deployment or anything like that, but one thing we've learned and observed ourselves and heard others echo is that when you release code frequently, it very much reduces the risk of reducing code when you didn't plan to, because you have all of those processes in place. And, how do you do this? You've built automation. And the changes are usually smaller. But okay, this was an interim unplanned release, basically. It was and literally the only thing that changed was the lines of code directly relevant to this patch. We didn't wait until the next sort of end of cycle. So what I'm asserting here is that just because we patched the bug doesn't necessarily mean that we were done with our response. And I think some people maybe some organizations maybe make this mistake where they, okay, well, we patched the thing. Now at this point, we either immediately draft and send out some sort of advisory, or even worse, they could say, hey, well, since this was, we were able to patch this ourselves without any customer impact, maybe we just forget about the whole thing and move on. But we didn't think that was the right thing to do here, and we did think that there was more work that needed to be done to protect and benefit our customers. And just to go back to the ISO standard for 1 second, when it's talking about how you draft advisories, it says this. It says, users reading an advisory need sufficient information to make informed risk decisions about how to remediate or mitigate the vulnerability. And in order to have this information, we had more work to do. But before even getting there, one thing you might want to ask is, well, who are the users reading this advisory? At Duo, we've made a habit of using user personas throughout the sort of product design and development process, because there are lots of different sort of categories of people who interact with our product. And when we have discussions internally about who a feature is targeted at or whose problems we're trying to solve, we need to be unambiguous about who we're talking about. And so in this case, we're mainly talking, and frankly, in a lot of cases, and when we're building Duo product, the person we're talking about is probably this guy, Gary, the IT administrator for, whatever organization. By the way, I know that using Eve for something other than eavesdropper is kind of unfortunate. Somebody else came up with these, and it's kind of stuck now, so oh well. So, okay, so we know we're thinking about Gary's needs. What does Gary need? Well, basically, again, as the ISO standard said, Gary needs sufficient information to determine his own risk, and based on that, appropriate workflows to do remediation and reestablish confidence in his systems. So we want to, and then of course, in all of this, we also want to be transparent, we want to be fast, we want to make this simple for Gary. These are kind of conflicting motivations, so we try to balance them as best we can. So on that first point though, you'll often see advisories that say something like this. Say something like, we have no evidence that these vulnerabilities have ever been exploited, or we have seen no evidence that these vulnerabilities have been exploited. I want everyone to understand what this actually means. It means the authors don't know if anything happened. Maybe it means they didn't even try to look. To be fair, sometimes the data is not available, and this really is the best thing you can say. I've had to write advisories that say this. But when we can do better than this, we should. And so, okay, let's go look. Where can we look? So this was a little bit tricky for us because we had kind of two different sets of logs in two completely different systems, each with some pretty significant limitations that could be used in this investigation. The first set was application kind of debug logs. These are run through an ALK stack and used internally for debugging our system, understanding what's going on. They're only retained for about 90 days, but they're highly verbose. And the other is, I'll call them audit logs. These are the kinds of things that you actually see in our product as if you're Gary, you can log in, you see logs of every time your users have authenticated, every time administrators have performed state-changing actions to configuration. And these are actually retained indefinitely by default, although customers can choose to shorten that. And so we had 8 days spent with two kind of parallel teams of engineers working on building and refining analysis tools to kind of do signature matches for patterns that would have shown that this vulnerability did or did not happen. And this is, yeah, sure.
Did that start in parallel with the mitigation process, or was that serialized?
This was after we did the fix. Just because the fix happened so quickly. I think if the fix had been going on for a few days, we would have executed these in parallel. But so, and even after 8 days, we still hadn't exhausted all possibilities of what we could look for. But at some point, we had to say it's probably not worth continuing this process. And yeah, and this is definitely not as awesome of a number as saying, hey, we patched the thing in 1 day. Now we spent 8 days dicking around looking through the logs to figure out what happened. But that's kind of what we had to do. And so what did we learn at the end of those 8 days? Well, from the verbose logs that we had the preceding 90 days of, we were able to say with high confidence, the only people who had exploited this vulnerability in that period of time were the customer who reported it to us, and then us in confirming and retesting the vulnerability. And when we looked at the sort of much lower fidelity audit logs, we were able to come up with some sort of patterns and say, it was basically a detector for potentially questionable events where users had edited their devices that had a pretty high false positive rate and an almost non-existent false negative rate. And so we were able to rule out for something like 90% of our customers this exploit ever having happened. But for the remaining 10%, I may be making these numbers up. This is a guess at this point. But say for the remaining 10% or so, we couldn't be certain. We felt reasonably confident that all these things probably were false positives, basically because of the 90-day thing, and expected that if attackers were exploiting this thing, it would have been ongoing. But we couldn't say for sure. And so, this is kind of one of those cases where we say, all right, well, we need to write up an advisory and contact customers. If we'd actually proved that no customer had ever been impacted by this, possible we would have done something different. But that didn't happen, so I can't say for sure. So what we did get from this for those possibly affected customers was a set of specific events. And for many of them, it was fairly small. It was like these 5 users out of your 200 might have had something happen. And so we needed to provide, so this was like tailored per customer data that we needed to provide. And that's a little bit tricky because normally our advisory process is that we send out an email blast to all of the customers who might have been directly affected or need to do something. And then we just post the text of the advisory publicly on our website. Neither of these things are great for sending like tailored per customer data. So we kind of had to build something different here, and we ended up deciding to build a feature within our admin interface to handle disseminating this information. And then beyond that, we also had to provide, which is kind of what's pictured here. Beyond that, we also had to provide some remediation steps for customers who wanted to, who were concerned about what happened and wanted to take action. Of course, one option that they had, and as I'll say later, many of them chose to do, was basically say, trust us, was basically for them to just trust us when we say, probably nothing bad happened. But we also said, hey, another thing you could do, especially if only a small number of users was affected, just go talk to them, have them look at their devices, make sure there's nothing fishy. But we also built an automated tool that would basically go through and lock out all of the users who had potentially questionable events. And all of this interface, so there's some more screenshots and warnings that like, yeah, this is going to lock out a bunch of your users. It's going to be quite disruptive. We went through multiple iterations of this. We pulled in our user experience team to help design these things. And ultimately, this took us about 2 weeks to build and test these automation tools, these delivery and remediation tools. And I'll say, again, that this was serialized after we completed the investigation because what we did here depended on the results of that investigation. And this was actually a much bigger code deploy change than the initial patch. So we had to go through a lot more sort of testing and qualification to make sure that adding this whole new feature wouldn't break the product for our customers, right? That's part of why it took a while for us to get this fully deployed. So far I've talked basically about the role of kind of our security team and engineers, because we had like probably at least 12 engineers working on these multiple phases I've discussed. But really there were a lot more people in kind of non-technical roles who contributed a lot to this process. And so on day one, when we start our vulnerability disclosure playbook, we bring in product managers, say like, okay, kind of for visibility, like this might blow up the roadmap. And they also have a good understanding of the product and might actually have ideas of like, okay, well, if this is broken, maybe that thing over there is also broken. You should look at that too. We bring in our technical leaders from our technical support or customer success team, because if we're trying to keep in mind the needs of our customers, they're the ones whose job it is to talk to them all day, and they probably know the customer's needs better than the rest of us. We bring in our legal and PR teams, mostly for visibility, We're not having them like spin the hell out of this so that it looks too positive. In practice, they've mostly just sat in the room and been like, seems like you've got this under control, just keep doing what you're doing. But we need to have them around because if something happens, if something blows up in the public sphere, they need to be prepared to respond to it. So this is not even a complete list of all of the people who participated in this response activity. And then kind of for the rest of the company, internal communications are still quite important. Because when you have like senior leaders from security, engineering, legal, et cetera, in a conference room, word starts to get out that something's going on. And so, we've gotten in the habit of what we do, send out a pretty early, once we've confirmed we're starting this response playbook, we say, send an immediate act to the whole company saying like, there's a thing happening, it's under control, basically don't worry about it, but also make sure you don't talk about this publicly before we're ready. Give regular updates to our department heads, and then before we actually do start contacting customers, we need to send sort of another announcement to the whole team of like, hey, this is happening. You might hear from customers, and here's what you should do about this, and here's what you should do if that happens. Here's where you can send that for additional help. And finally, I think we did better this time around, but on a previous disclosure exercise, we didn't do a good job of communicating context to our team that like vulnerability disclosure is kind of a normal and inevitable process of running a software company. And so they thought the sky was falling. They thought our company was about to go out of business because of this thing. And like, we needed to clarify that like, this is serious, but it's not that serious. And so, okay, once we sort of finish the remediation tools, we're ready to go, contact our customers and kind of be public about what happened. And, kind of going back to the original, the intro slide of Rich complaining about timing, this is something we thought about, and we say, okay, when should we send an advisory? We've basically ruled out Monday and Friday. Especially Friday. And actually, like Tuesday seems ideal. Microsoft maybe figured this out a while ago. And we also pretty much always go for the morning, not too early in the morning, but morning Eastern time. And this allows our company is headquartered in Ann Arbor, Michigan, in Eastern time. We have operations in California, we have operations here, and in London. And so morning Eastern time kind of, with some advance notice that, hey, maybe people on the West Coast should come in a little early, lets us maximize support coverage, maximize the number of people who are ready to answer the phones if a lot of customers suddenly start calling. This was kind of actually a thing that, this was one of the lessons we learned the hard way. A couple of years ago we did an advisory, didn't really talk to the support team, and then mailed it out at 4 p.m. Eastern time. And at 4:30, all of the support, a good chunk of the support team was planning to go home, and then the phone started ringing, and they were mad at us, and they had every right to be. And so things like this are a good reason why leaders from those teams need to be at the table when we're deciding how the process proceeds. We actually set up like a war room and conscripted some other people who are not normally tech support people to be ready to answer phones. But actually, it was kind of a non-event when we did this. We emailed about 800 customers, and we had our customer success team actually call on the phone 100 or so largest of them to say, hey, there was a vulnerability disclosure we just did. You might want to take a look. Just, heads up. And we had some metrics on how many people opened the email, how many actually accessed the landing page. And kind of the interesting thing was that 0 customers used that functionality that we built to automatically lock out their users. And we had, 2 calls and 2 emails all day. What we did here, in terms of feedback was actually really positive. Most of our customers basically thanked us for the transparency, and many of them were really impressed that we had proactively called them, said like, no other vendor's ever done this. Names were removed, but I think the quote at the bottom actually came from the customer that reported the vulnerability to us. So they were also, I think, pretty happy with how we handled this. But even if they were happy about how we handled this, am I happy with how we handled this? Did we actually spend the right amount of time and effort doing this investigation or remediation before we actually went out and contacted these customers? Well, this sort of goes back to my original point. What we did in the moment was we said, are we doing the right thing for our customers to both keep them safe and also kind of reduce, prevent them from being unduly burdened by this process? And so I think the choices that we made, I feel, are defensible. I don't know if the result was, in retrospect, especially given that nobody actually used that lockout feature we spent a week building. Maybe we could have not done that, but in the moment we didn't know that's what was going to happen, and so we did what we thought was right. One thing that I think was clear is that some of these things, we needed to put ourselves in a better position so that the next time this happens, we can get all of this done more efficiently and in less time. Because in addition to just the amount of time that elapsed before we were able to contact our customers, which makes me uncomfortable, there was also the amount of time that our engineers had to spend working on this instead of building new features that actually make us money, frankly. And we were only able to do this because either because we're awesome or more likely because we're lucky, we don't do disclosure that often. If this was something we were doing every week, like in Adobe or something, there's no way we could go this deep on it. We just wouldn't be able to justify it. And other interesting question might be, hey, what if the investigation had revealed something very different, like all our customers are being actively exploited right now? I'm not sure if I have an answer to that. We probably would have sent a notification out immediately instead of waiting, but other than that, it's an interesting scenario to think about. Okay, so sort of to sum up all of this, ultimately, security advisories are facilitated by the security team, but really a wide range of stakeholders in the company are necessary to determine the best course of action for customers. And a little bit more specifically, say it one more time, at every juncture in this process, if you really consider the needs of your customer first, use that as the primary way that you make decisions here, things will probably be okay. Or at least, you'll be able to defend your choices when people question them. And kind of along this way, remember that deploying a fix is not necessarily the end of the road here. There might be more work that you need to do to make sure your customers are cared for adequately. As we saw, a well-handled vulnerability disclosure can actually make for really positive customer responses. It can make them trust you more. We've actually had incidents, maybe not, I don't remember if it happened with this particular advisory, but on previous times, our customer success team has called up a customer and said, the message is basically like, hey, sorry, we screwed something up. You got to go update some software now. And the customer said, oh, thanks. By the way, I want to buy more of your product. So he actually turned vulnerability disclosure into an upsell, which is weird, but it happened. But also, finally, keep in mind that a well-handled vulnerability disclosure involves a lot more of your team than just the security team. Thanks. Probably have time for one or two more questions if there are any. And happy to speak after this too if you have more questions. If you think I'm totally wrong about all of this, I'd love to have those sort of discussions. It's downtown. It's at 5th and Brazos.
So you didn't use the word empathy in your process itself.
Yeah, well, I'm trying to be a little subtle about it, but empathy is understanding what the needs of your customer is, so at least that's what I mean in this context.
How does the discussion happen on whether or not you're looking into logs? So when you did the dive into the application logs, how did that trade-off look like in terms of, are we going to do it or not? If it were more complex, would you have even done it? I'm curious about trying to get resources to do that sort of thing for an incident.
So, I don't know if there was really that much discussion. We sort of started already from a place of saying, like, we should do this. How do we do this? It wasn't is this a thing we could spend time on? The question for us has always been more like, what are our capabilities here? If we wanted to answer this question, what could we do? And like I said, sometimes we've done disclosures in something that's like a piece of software that customers install on their own machines. So we don't have much, if any, log data from that. And then that's when we have to say, like, honestly, we don't know what happened, and we have no way to figure out, and we have no way to do better than that. But in this case, it was just sort of like, here is, we have some data, let's look at it. Now, the more interesting discussion was probably, like I said, 8 days in, we're like, okay, well, we still don't have perfect answers, but we're not gonna get any further. We have a culture of doing retrospectives, blameless retrospectives. It's good. And so we tend, through one of these things, we actually try to kind of split retrospectives up. So we do one on how did the process of the vulnerability disclosure go, and do a second one on, okay, what about the actual bug that happened? How can we prevent that in the future? And so, yeah, we absolutely did have some of those conversations. The piece of code this happened in is kind of Byzantine and hard to understand, and there are teams that work right now on cleaning, major efforts to clean that up. So, yeah, but we considered that too, of course. Well, you can always do more testing, but whether it's going to catch all of the bugs is, no, in the end it won't. In this particular case, there was kind of an even funnier backstory to this, which is that I personally audited some of the code in like a year or two before this vulnerability was discovered, and was looking at it and I said, I think there might be a problem here. And then I spent some time poking at it and I was like, I'm wrong, it's fine. So like, there's something to be said for kind of when you're kind of an AppSec person and you have a concept of like code smell, I guess. When something looks funny, you can't necessarily prove that it's bad, but often that does mean that something is there. But this had run. We tested this. We'd had third parties do AppSec assessments, and
Yeah, exactly. That's the same thing. That's what we didn't have in
Me again. It's a frequent development process that you always have a second person read the code that's checked in. Neither of those people are necessarily security people, so would you recommend a third person who's a security person review every check-in?
Well, I think Matt's talk earlier today asked the question, does anybody here feel like they have too many people on their AppSec team? If you have enough people on your security team that you can do that without slowing down the velocity of your feature development and without, without pulling them off of other work that's more impactful, like, sure, but that's never going to happen. There's no way that we can especially considering like financial responsibility, there's no way we'll be able to build an AppSec team large enough to do manual review of every piece of code that gets checked in. So what is potentially useful is finding out where the really dangerous areas of your code are. You can flag certain subsets and say, okay, this deals with implementing crypto. Someone from security should look at that. This deals with kind of the critical authentication path of our product. Maybe either a senior engineer or somebody from security should look at that. So there are places where that approach is potentially useful. It's just, it's not something that you can do everywhere.
Any other questions?